Hello, everybody. Good afternoon. Can you hear me?
Yes, hello.
Thank you, Victoria.
Yes.
Hello, hello.
Hello, hello, hello. Happy Monday, everybody. Oh, dear. All right, let's see what we're doing here. That's not the right course. That is not going to be helpful. There we go. Okay, let's see what we're doing here. Okay. Move this all around here. Okay. So, let's see, is it 12? That's not quite yet. Okay. All right.
I don't know why, but I'm having some problems trying to log into the server for going through the computer. Like my course's site is down.
How is it?
Yeah, it's just for me, I think. Yeah, I don't know why.
I'm not sure. Maybe you should call the help desk, 341 help. Maybe they can help. Possibly, I don't know.
I have no clue.
I'm not having a problem, but then again, I'm connected through the school, so I'm the worst person to ask about it right now.
Yeah, it's saying that the IP address cannot be found, so I'm just going to dial in over my phone.
All right. Okay. Anybody else having issues getting into my courses right now?
No.
Okay. Okay. Well, it's 12:30. We'll get started here. Good afternoon, everybody. Thanks for joining me. Thanks for coming today. Appreciate your being here. All right, we're going to look at isomers. What are isomers? Isomers are compounds that have the same molecular formula but different structures. Oh, wow. All right, so we have something important here. Carbon always has 4 bonds. Nitrogen always has 3. Oxygen always has 2. Halogens always have 1, and hydrogen always has 1 bond. So that's going to be requisite knowledge here. So here's an example. Draw isomers of C3H7F. So there you go. C3H7F. Now I'm going to try and really push you down the line, push you down the direction of line structures, right? So we're going to be talking a lot about line structures here. The reason I go for line structures is because they're a little bit less confusing and they kind of cut through the rigmarole, if you will. So I've drawn 2 isomers here of C3H7F. And you'll notice if you look at the line structures, they're the ones down the bottom here. You can see how easily you can distinguish between them. We have one where we have the F coming off the middle carbon, and another one where the F is coming off the end. So we know that those are the only 2 structures we can draw, by the way. So a couple of things that we know. First of all, something like this. Whoa, Richard. No, I need to get back to where I was here. There we go. Okay. So something like this, where the F is on the end, that one would be the same as this one here, where the F's on the other end. All right, so that's a repeat. That would be the same thing. Kind of think of it like flipping it around, like flipping over a pancake. Anybody got any questions so far? Okay. Now, the other thing we know is that, well, actually, let me do something else here. Oh, no, that's okay. That'll do. Something like that is impossible. Why? Because up here, we already know that halogens can only have one bond. So I can't draw anything where the halogen is in between two carbon atoms. I could if it was an oxygen, but I can't do it if it's a fluorine. So that's what we've got so far. But this is kind of requisite knowledge here, especially carbon, oxygen, halogens, and hydrogen. We're not going to really focus too much on nitrogen, but it does have 3 bonds, and you would have to take that into account for any isomers you were drawing for that. So what do you need to be careful of? Well, you need to be careful of, first of all, making sure you draw all the possibilities. The other thing you want to be careful of here is making sure that you don't repeat any structures and you don't draw any illegal structures. Okay. So this is something a little bit more, well, I'm not going to say more advanced, but it's a different one. C4H9F, and you can see the strategy I've employed here is I've looked at the carbon skeleton and I've tried to figure out how I could rearrange that before I placed a fluorine in different locations on that skeleton. So these are the 2 possible ways that we can set up 4 carbon atoms. We can set them up as being 4 in a row or 3 in a row and then 1 off the middle like this, sort of like an airplane propeller. But that's it. Those are the only 2 possible ways that I can arrange 4 carbon atoms. I'll stop there for a second. Does anybody have any questions so far? Okay. So when you're looking at these first 2 here, and what I've done is I've put the fluorine in different locations on this chain, right? So I've put one here at the end, and I've put one hanging off the second one. All right, so let's go ahead and I'll show you exactly how I'm doing that. So there's my 4 carbons, remembering that there's a C at each of these points that I'm pointing to. And then when I put an F here, I have to draw a bond off to it like that. Because I can't do this. Now I see this all the time. It's kind of like people they're not sure, so they want to fudge it a little bit. Well, where's the F go? Does it go at the end, or does it go at the end of another bond? I think I'll just put him right there. Now, that's not right. I don't like that at all. If you're going to do it, commit. Commit to it, right? Commit to a bond. So I go ahead and I put my F, let's see, where am I going to, I'll put it here. All right, that's cool. And you might say, all right, let's go ahead. We'll stick him here as well. All right. What's the problem with that?
It's a mirror image.
Oh, yeah, it's the same thing. I mean, having the F here on the second carbon is going to be the same thing. I put the F on the end, it's going to be this one here as well. So that one's off the table as well. So these are okay, but those aren't. Not so much. All right. Anybody got any questions so far?
So no resonance in the.
No, because there's no double bonds and charges or anything else. So we only have that when we have resonance. Now, the other 2 possibilities, so are based on this one here, where you've got the 3 in a row and then 1 off the middle. And we can put the F hanging off that very central carbon there. And then we can put the F off any one of these, knowing that whichever one it comes off here, it's going to be the same thing. So think of it like an airplane propeller and just twisting the airplane propeller. You're not really changing anything by putting the F on any of these carbons that are on the outside of the airplane propeller. So again, it's a matter of being able to look at these and be able to figure out, okay, what's the same, what's different. All right, so that's the very basics of drawing isomers. So let's have a squiz. Let's go back to, hang on, I have to, okay, let's go back to here. Yes, am I on the right? Yes, I am, okay. So in the Isomers folder, this is what I want you to look at, supplementary isomer problems. And here they all are here. And the idea is that I've drawn a bunch of isomers for each of them. Oh gosh, look at that. All right. Now here's my promise to you. The one you get on the test will be one of these. Okay, so it's going to be one of these. And you have my word. This is my word, my solemn word. Anything I give you is going to have fewer than 15. Okay? You have my word. You have my word. Fewer than 15. Usually I get some reaction to that.
It's very reassuring.
I was waiting for somebody to say something. I usually say, well, may lightning strike me down if I give you more than one that has more than 15 isomers on it. All right. We'll continue on. So some of them, as you can see, just have one. Some of them have 3, some of them have 5, etc. All right.
Is there any trick to figuring out how many they'd have?
Great question, Julie, but the answer is no.
I hate it.
Your only friend is trial and error, and I don't tell you how many there are.
Okay.
all you know, it's less than 15.
Oh yeah, that helps.
All right, let's have a look. This is a good one. I'll do C2H5OF, all right? And this is my example. I'll give you an idea about strategies for these. But knowing that you're going to get one from that list means you can practice them, right? That's the whole point. Okay, so C2H5OF. Whoops. All right. So if I'm looking at that, there's only one. Well, okay. What I would do, and this is a strategy I show in the video. Figure out ways that you can arrange things that have more than one bond. In this case, we're talking about the C, the 2 C's and the O, right? That's it. Figure out what you're doing with those and then figure out the hydrogens and fluorines later. Actually, in reality, it'll just be the fluorine you'll be worrying about. I wouldn't even worry about the hydrogens. They end up taking care of themselves because I'm telling you, all of these, none of them have any double bonds in them. None of them are cyclic because they don't have the requisite number of hydrogens to allow that. So they're all going to be things that are pretty much straight chains and branches and things, and that's it. So if I've got 2 C's and an O, there's only 2 ways that I can arrange that. I can do this. I can do CCO, or I can do COC. That's it. There ain't no more. I cannot do any other combinations of C's and O's. If I do that as a line structure, and I'll go ahead and do that now, that's what we're looking at. That's going to be our base structures. So now I've got a fluorine. I've got to put a fluorine in different locations. All right, so let's focus on the top one first. I can do this. I can put an F on the O, or I can do this. I can do that in 2 ways. I could do that. let me,
Can I ask a question?
yeah.
Okay, what is it that made you decide to only deal with the C's and the O's first? What, like, what?
Because they are capable of bonding more than once, Julie.
F is only capable of bonding once?
Yes,
Okay.
indeed. So is hydrogen. So I can do this, O, and put the F here, but that would mean I put an H on the O here. And one more, put the F down here. So that's it. That's all I can do on the first one. Now on the second one, I can do this. So notice in each case how I can put a bond off to the F. I didn't when I did the OF initially, but you know, I can express that either way. But that's it. Those are the 4 possibilities there. I can't put the F anywhere else. You might be wondering, why can't I put the F off the oxygen here? And the reason is I can't, because oxygen's already bonded twice.
So what's the difference between O, like the O bonded to F, and then OF?
There isn't one.
Okay, so
It's like when I do OH, right?
Oh yeah, I got you.
It's the same deal, really.
So I don't see where there's 4. I'm sorry.
Oh, for isomers?
Right, because you only have, because you're saying OF and O-F are the same.
They are.
Something going off the page that I'm missing here. I'm thinking maybe I don't have the whole page here.
Oh, well, I mean, I've just check marked all 4.
I only see 3, so
Yeah,
obviously I do not see this page right.
Yeah, I'm not sure.
Okay.
Can everybody else see 4? Oh, thanks,
Yes.
Victoria. So
I
I
see
don't know,
4.
I don't know, Julie.
Okay, I just moved it. It's the way the Zoom was set up.
Oh,
It's
okay.
fine. I'm looking at it going, I only see 3.
Okay. All right, so that would mean there's only 4. That's it. That's all you can draw. But as you can see, it's a matter of trial and error. But you try and do it by, well, you try and be organized about it at least. All right, I'm going to show you another one here. Let's see. C2H6O2. We'll do that. Okay. So again, I focus only on carbon and oxygen here because those are the ones that can bond more than once. I ignore the hydrogens for now. All right, what I want you to do is I want you to come up with the carbon-oxygen combinations that are possible with 2 C's and 2 O's. All right, so I'll give you a minute to do that. It's not as easy as you think. And I'm going to warrant that a number of you have forgotten one, but we'll see. We'll see. I'm pretty excited. All right, let's see. Can somebody, well, actually, I'll just go ahead and do the ones so we can do 2 C's and 2 O's like that. We can do that. We can do a C and 2 O's in the middle like that. We can do CO like that. We can do O's on the ends like that. And we can also do this as well, which is probably the one that you might have forgotten. Ooh, tricky. All right, so does anybody have any others that I might have forgotten here? Any thoughts?
Can we do the same thing that you just did, only with the C hanging off of it?
Only with the C hanging off it.
It's, in other words, OOC and a C hanging off the bottom?
Okay, like this, right? Okay, like this, Julie. Yes. Yes.
You couldn't do the one in the middle.
No, not like that.
Why?
I already have it up the top here.
Confused.
That's the same. These two are the same. The ones that got arrows on are the same, Julie.
I think she's asking why
Oh.
can't you have the carbon hanging off the oxygen central atom and that one you just drew?
Right.
But it's because oxygen already has 2 bonds on it, correct? And that's the max.
Yeah, I'm just trying to see which one. Oh, okay, okay. I think I get it. All right, hang on. Like this. Yes?
Right.
Yeah, no, that's right.
Because it's too many bonds.
Too many
Okay.
bonds. Yeah, O can only have 2 bonds.
Okay.
That's no good. Sorry. Yeah, I think that's it. Are there any other that anybody can come up with? So some of you might have had this bright idea as well. Right, but that's the same as this. That's the same as this one. All right, I mean, it's all it is just twisted around. The connectivity is the same. That's the challenge, you know. So let me put the line structures on each of these. You'll notice I do angle them. All right, so that's all the line structures. So really, it's now just a matter of, because there's no Fs or anything I have to put on, I really just have to put the hydrogens where they need to go. And I'll put hydrogen here, and here, and here, and here, and here. And I shouldn't have drawn one there, but I did now. It's there. And that would be it. So that would be the 5 possible isomers that one could draw for C2H6O2. Now, you might be wondering, well, do you have to make sure the hydrogens are taken care of? No, not really. They're all going to have 6 hydrogens on them. You count them up yourself, but you don't have to worry about it. As long as you do what I just said to do, you should be okay. Now, the thing is, on the test, it's not all or nothing. You know, you'll get partial credit if you do some of them. You tend to lose points if you repeat them. You also tend to lose points if you omit any. So, you know, it's not that okay, I admit it is kind of hard to get 7 out of 7 on the question because it's worth 7 points. That's not to say there's 7 isomers. I'm just saying that that's how many points the question's worth. It is hard to get that. But most people generally get at least 5 points. So it's not too bad. But it is the most annoying question on the test for many people. They don't like the isomers.
And the trick is that you're not telling us how many isomers there are, right?
That is correct. That is correct. But you do get to practice them. Sorry, there was a question there.
It'll always be less than 15?
Yes, absolutely.
Boy, it would be really nice if you told us how many there were.
That's not going to happen. Yeah, I do take a little bit of glee in that, but oh well. All right. Any other questions about this? All right. Well, what I'll do is I'm going to leave that to you, and I'm going to get you to practice it a bit, and we'll look at it on review day. Okay. In the meantime, you know, practice, and don't stop practicing. Don't stop till you get enough. Okay. Any other questions about isomers? Okay. Let's go back to where we were at. Okay, functional groups. So compounds are classified by the kinds of structures they contain. For example, OH we call the functional group for alcohol. So these are, well, what I actually, you know what? These days, I'm super kind these days, and I actually provide you with this table without this real example here. So you actually don't have to memorize the functional groups and their structures. I used to make people do it, but I don't anymore.
That's
You're
going to
the
be
best.
provided on the
Thank you.
test.
Yes,
Yeah,
it
thank
will.
you.
Yes, it will. But not this column here with the real example, just these two columns here.
That's
So
perfectly fine. That helps me so much.
well, actually, you'd be surprised. People do no better on this question with this than without it. It never ceases to amaze me. Because, people say, oh, yeah, that's great. Oh, yeah, I'm going to get 100% in this question. No, they still don't. They don't practice it enough. Ah, dear. All right. Now, here we go. Here's our functional group list. All right, let's see what kinds of questions are you going to get on the test. All right, let's have a look. So in the blue book, or this problems test 1, all right, let's have a look. Here's an example of a question. So question 7, circle and label each one of the functional groups in this drug. Choose from the following list. If a group appears more than once, label only one instance of that group. And then I give you a whole list of all the different functional groups except alkane, because most of them have alkane in them anyway. So I don't worry about that one so much. You'd think it'd be easy, wouldn't you? Since I do give you the list here, alkene, alkyne, ether, all right? And plus I give you the actual table here that shows all the structures. All right, so this one, for example, only has 2 functional groups on it. Let's see, I'll show you the answers here. There we go. So we have a ketone and we have a carboxylic acid, and that's it. So those are the only 2 in that one. So there's an example. That's how yours is going to look as well. I use this website called drugbank.ca, and I just pull one off there generally. There's only like 100,000 there. Good luck finding it. But all right, let's take a look at some other examples.
Sorry, did you say that you will be giving us a list, or you
I
won't be?
did. I will.
Okay, awesome.
Will. And if I don't, may lightning strike me down. Yeah, it's not as effective on Zoom as it is in the real class, but anyway, why do that? There we go. So I've got this worksheet here. This is towards the end. Identifying functional groups practice. There we go. So let's pick one here. Let's do midodrine. All right, so what I want you to do, hopefully you've got a pen and paper there. I want you to copy that down, please. Copy it down on a sheet of paper. There we go. Midodrine. And I want you to circle any functional groups you see. Now, it's not as easy as it sounds. It's a little bit tricky here. Let me point something out. Let's say you've got a carboxylic acid, right? If you look at carboxylic acid, C double bond O to an OH. And you might argue, well, hang on, isn't that an alcohol as well? No, it's not an alcohol. OH is alcohol, but OH connected to a C double bond O is carboxylic acid. You have to keep that in mind. when you're doing this. So go ahead and write it down and circle any of these functional groups that you see there. Can you all see that, or do I have to enlarge it? Functional groups.
It's kind of small.
Kind of small. Okay. Let's see if I can.
It's just hard to read the subscripts,
Oh, the subscripts.
like the H something C. I can't quite see that.
Okay. I'm just trying to. I'll see if I can enlarge this a little bit. Yeah, that's about as best I can do, I think. Oh, maybe. Oh, hang on. Well,
You may be able to zoom in on the PowerPoint screen, like
hmm.
at the bottom, like increase the zoom.
Oh, yeah. Let's try that. Oh, yeah. But then I lose part of it. Anyway, it's a little bit better. I'll make it 65%. Thank you. There we go. That's probably about the best I can do. Ignore this column here. I just want you to focus on the functional group structures here. Don't worry about these guys over here. So we're looking at midodrine here. All right, so hopefully you've drawn this out, and now you're busily circling functional groups and then writing them down. Now remember, if there's more than one of the same thing, only circle it once. And this one does have more than one of the same thing.
Did you want us to name the functional group as well?
Yeah, yes, you'd have to do that on the test as well. So you have to circle it and then put the name of that functional group next to it. All right, and let me show you what the answer is to that. Okay, there we go. So we've got an amine up here. That's CnH2 group to a C, and that's this one here, but I'm circling CnH2. We have an amide here, that's an NH connected to a C double bond O, that's this grouping down here. We have an OH, which is the alcohol, and then we have an ether, and that's an ether as well on the other side. And you know what? I missed one, didn't I? Which one did I miss?
The alkane.
Nope.
The aromatic hydrocarbon.
Oh, the aromatic hydrocarbon, this puppy here. I didn't circle it. Yeah, that's part of it too.
Not even you are getting all the points in this question.
No, I didn't, Francisco. You're right. I would have had to mark myself off. Oh, terrible. All right, so that's what you'll have to do. Does anybody
So I
have
have a
any?
question.
Yes.
So for the alcohol one, could you have it as an aldehyde?
No.
Could you have the carbon, and then the OH?
No, because the aldehyde is specifically a C double bond O with an H connected to it.
Oh, okay.
Has to be that. I don't know if there's one here that has an aldehyde. There might be. I'll see. Let's see if we can find an aldehyde.
Where was the second ether you said? You said there was another one. Is that
Right.
on the other side?
Yeah, on the other side, right across
Right.
from it.
Okay, that's what I thought. Thank you.
I'm just trying to see if there's an aldehyde on any of these. It appears not. I don't think any of these have aldehydes on them. Yeah, aldehydes are kind of not that common because they're very reactive, so not very many compounds really have them. I'm not saying they don't exist, but they're They're a little bit tough. They're a little bit harder to come by than, say, ketones, for example. But anyway, that's some practice for you for that as well. Plus, you've got the old tests as well for that. Yeah, it's just a matter of getting used to it. Now, a couple of things I want to point out. Do you see these funky bonds here, like these wedges? Like that one
Yes.
here? Yeah, the wedges still are just regular bonds. They're showing what we call stereochemistry, which is like a 3D type situation, but it's still consider it just as a bond. Likewise, down here, see this is a, let me see, I'll see if I can. You can see these kind of wedges and then dashes. Those are just considered to be bonds as well. So that's not going to be affecting anything that you talk about. All right, does anybody have any questions about functional groups? Okay, so again, I'll get you to do some practice on those on your own, and then we can talk about those on review day as well. Generally speaking, it's not too bad. I mean, I wish people would do better on it, but they're just not careful enough, and they just don't take enough care when they're actually looking at the problem to make sure they pick up all the functional groups. I tend to treat it when I'm doing it. I'll just show you when I'm doing it. If it's me, I kind of like to, oops, let me find a problem here. Here we go. I like to treat it as a checklist. I ask myself, is there an alkene? And I put a cross there for no, alkyne, no, ether, no, etc. Until I go through and I've check marked everything, and then that way I don't miss anything.
Now, are these all the possible functional groups, or just the
Yes.
one that we're going over, the ones that we're going over in this class?
But these are the main ones that most people. There are some others though, yeah. But these are the most common ones. This is the hit parade. These are the ones that people most often talk about. They're functional groups that are somebody. Yeah. There's a lot of nobody functional groups out there though. I can tell you that.
There were a lot of methyl groups in biochemistry.
Yeah, well, methyl is just CH3 though.
Mm-hmm.
Dr.
But
Moss,
but as far as functional groups go, there's a lot of P, like P double bond O and that kind of thing that we're not really going to get into, like phosphates and all of that. But no, we're not going to worry about that too much.
Dr.
All
Moss,
right. Any other questions? Victoria, do you have a question?
Yeah. So if we look at the alkene, for example, right? It's
Yes.
just only one group. But when we look at the amide or amide or amide, I'm not sure.
Amide, yeah.
Amide, there's like 3 examples. So how do we interpret that? That
Well,
there's 3 versions of it?
The reasoning is that C double bond O to an N is really the amide functional group. But there are 3 flavors of amide. You can have 2 hydrogens on a nitrogen, 1 carbon, or 2 carbons. But the N C double bond O, that's the core of the amide group itself.
Okay.
But I had wanted to include all of them because, you know, initially when I was doing this, that's all I put was C double bond O N, but it was confusing to people because they weren't sure, oh, well, there's a hydrogen or a carbon. Does that mean anything? So I just decided to cover all my bases. It's like the amine here, same deal. Any other questions?
Once we label a group, it can't be anything else. It can't participate in 2 group structures, correct?
Not generally. Yeah, I'd
Right.
say that that's true. Your circles should not be overlapping.
Okay.
Is that all right?
Yes.
Okay, any other questions? Any other questions about functional groups?
Is each part of it like a functional group always?
Is each part of it like a functional group? I'm not sure what you mean by that, Courtney.
Like every single grouping of, like, could you label the whole thing and like
Well, I mean,
cover every
I
atom?
think I know what you mean. Like, see, like for the ketone, I would just.
Well, there would
I
be
think she
carbons
means, is
that
there
don't
any part
participate
of-
in a functional group, right?
Like for the
Oh, sorry. People are talking over each other, so I kind of lost you for a second there. Courtney, I'll listen to you first, and then I'll come back.
well, I was saying like for the one we just did,
Yeah.
like the label was that last ether. So technically each part was circled.
Oh,
except
yeah.
it was
Yeah,
just
but
like-
I also say in the question, just do one of each. One of anything if there's more than two of them, more than one of them. So you wouldn't circle both ethers here. You can circle one of them or the other, but not both. I don't know if that answers your question. I hope it does.
yeah.
I'm going to be fairly, what's the word? Generous, or, you know, I'm lenient. Yeah, fairly lenient when it comes to what you circle. As long as you circle something that looks like you're circling the functional group, I'll be okay with it. I think, Courtney, that's the basis of your question.
Yeah.
Yeah, because, you know, if you just circled the OH here, I'd be okay with that. If you circle the C with the OH, I'm okay with that as well.
Really weird question, but on the exam, are we allowed to use highlighters?
Oh, fine. Yeah, that's fine if you want.
Okay.
Yeah.
It's easier for me to see instead of having like all the circles all over the place. So
All right, that's fine. Whatever floats your boat, it'll be fine with me. Now, somebody else had a question, but I wasn't sure who it was, or a comment about the functional groups. It was a male voice, but that's all I got. Okay. All right, any other questions about functional groups? Okay. All right, so we'll get into naming alkanes. All right. I'm just curious. I didn't check today. Usually I check, see exactly how far I had to get. I know I was supposed to do this stuff last time. I was supposed to do all this functional group stuff last time, so I didn't time it out quite right. So let me see what we're supposed to be doing today. Oh, yeah, it just was naming, yeah. All right. Wow, this test is coming up quick, isn't it? Whew. All right. I better get something organized. All right. Naming alkanes. Name to structure. Right. So first of all, you are going to have to be aware of the base chain names. Now, the base chain names I'm talking about, let's see if I've got them here. There we go. Here. These you'll have to know. But, you know, you probably know most of them anyway. So the base chains are, if you look at, we'll say, pentane onwards, I think you're all pretty much aware of what those prefixes mean. Penta is 5, like the building, the Pentagon. Hex, hexane, 6, like a hexagon. Heptane is 7, like the heptathlon or a heptagon. Octane is 8, like an octopus. Nonane, I don't know, just sounds like 9. That's about all I can come up with. You might know a nonagon, I don't know. And decane is like 10, like a decade. So the only 4, I guess, you really have to sort of memorize here would be methane, ethane, propane, butane. And that's going to be 1 carbon, 2 carbons, 3 carbons, 4 carbons. But yeah, you'll have to know the base chains. All right, so let's take a squiz. Okay, we're going name to structure. So here's an example, 3-methyl, 4N-propyl heptane. So you look at the end, and it tells you what the base chain is. The base chain is heptane, which is 7 carbons. So you can see what I've done there is I've labeled the carbon chain from 1 through 7. Any questions so far? Okay, the next part of it are the substituent groups, and those are the methyl and in this case the N-propyl groups. Now that I do actually give you a sheet for on the test. I'll show you that. These are called substituents or side chains, and you get this on the test. There's both of these pages here. Okay, so we've got the methyl, we've got the ethyl, we've got the propyl, N-propyl, we've got the isopropyl, butyl, N-butyl, sec-butyl, isobutyl, tert-butyl, and fluoro, chloro, bromo, iodo, nitro. Now, I give you this, right? I give you this sheet. I don't give you this last column, what it looks like as a line structure. You're going to have to figure that out on your own. So let me point out what the differences are between this and a regular compound. So a methyl is like a CH3, but it's not methane. Methane CH4. A methyl with the YL on the end is kind of like the group you get if you pull a hydrogen off methane. So that then can attach to something because there's a vacant space on it. Does anybody have any questions? So these line structures here are helpful, at least when you're learning, kind of like training wheels really, just to show you what these things look like as line structures. But when you've got something like propyl, when you've got 3 carbons, we can have hanging off the ends, that's called propyl or N-propyl. Isopropyl is hanging off the middle. It looks like a Y. So I kind of remember that like Y-sopropyl because it kind of looks like a Y. So butyl, there's 4 combinations for that. You've got one off the end, one off the second or sec-butyl, sec-butyl. One that looks like a Y, that's isobutyl or Y-sobutyl as I call it. And then tert-butyl, T-butyl, kind of looks like a T. Yeah, so those are the 4 possible ways that you can arrange 4 carbons as a side chain. So you'll get this minus the 3rd column there. All right, so let's show, let's show what that looks like. Oh, I don't want to do that. All right. Where was I? Here we go. So if I draw this as a line structure, you can see how it's going to go. All right. One, two, three, 4, 5, 6, 7. So that'd be the heptane line structure. Now N-propyl, let's see. So this is 1, 2, 3, 4, 5, 6, 7. The methyl group is off the 3rd one. So that's going to look like just a line there, and the methyl group is right here where I'm circling. That's the CH3. And then off the 4th carbon, I've got the N-propyl group, which looks like this. So there's your N-propyl there. So it's hanging off the end of that. So that's it. That's how we come up with it. Yeah. So going from the name to the structure is usually not that difficult. It's going from the structure to the name that becomes a bit more intense. Does anybody have any questions? All right, we can do something similar with cyclic compounds as well. So this one is called cyclopentane. So they're the same thing, it's just they have cyclo in front. It means it's like a circle. So cyclopentane is 5 carbons in a circle or a cycle, if you will. Now, it doesn't matter how you number a ring because you could have any starting point you like. So what are we doing here? We'll do, what is it? We got 1,3-dimethyl cyclopentane. So we'll have a methyl group off the 1, a methyl group off the 3. That's it. Does anybody have any questions? See, it didn't matter where I started the numbering on that. Which direction I numbered it. It's going to be the same thing. So what I've got here is the same as what I've got in that answer, believe it or not. Does anybody have any questions? All right. Okay.
Numbering. How are you numbering the structures? Like, does it matter which way you number it?
Not the circles, no. It does
Okay.
it does matter on the lines, like this.
Yeah, left to right, but
Yeah,
the circle
well,
ones, it doesn't matter.
Yeah, that's right. I mean, well, actually, you can even do right to left, but you do have to start at the end, either end on
Gotcha.
on this one here. So you could have done it the other way, it's fine too, but on
Okay.
a circle, it doesn't matter. Okay, so going from structure to name, now that's a little bit more hairy. Come on. There we go. All right. It's a little bit. Okay. So if I drew this as the line structure, here's what it will look like. Yeah, that's right. Okay, so that's what it looks like as a line structure. And this becomes a little tricky because what you have to do, the first thing you have to do is you have to find the base chain. And the base chain is the longest contiguous carbon chain in the structure. And that can be a little bit of a challenge to find, especially in one like this where it tends to meander throughout the whole structure. See, you might look at this and you might want to start at this left end here and go 1, 2, 3, 4, 5, 6, 7 and say, well, 7. But it actually isn't. That's not the longest chain. The longest chain is actually an octane where you start here 1, 2, 3, 4, 5, 6, 7, 8. So the base chain is actually going to be, I'm going to circle it. There's your base chain right there. And how do you know? Well, it's always the longest one. So it might take some trial and error, but you're going to have to find it.
Would it have been wrong if you started to the right and went around?
That would have been fine too, Julie, because that's kind of symmetric. So either side would have been fine.
Okay.
And it wouldn't change the name of it actually that way. Sometimes it does, but that doesn't make it wrong as long as you're using the longest chain, if that makes sense. Okay, so the next thing we would do is we have to figure out which way we're going to number it. Well, it does matter. We can either number it from number 1 at the top here or number 1 at the end on the left. So it can go right to left or left to right, but only one of them is actually correct. And how do we determine that? Well, what we've got to do is identify our side chains or our substituent groups. And we've got one here, I'm circling them, one here and one here. So there's all our groups. We have the groupings here. And what I have to do is figure out where they are in the chain and what numbers they would be on depending upon where we were numbering it from. So what I'm saying is if I number it from the left, then I end up with a substituent group on positions 3, 4, and 5. If I number it from the right, my substituent groups end up on 4, 5, and 6. So the idea is I have to number it so that the numbering is the smallest possible numbering set that I can come up with. And one way that I can do that is to add them all together and see which comes up with the smallest sum. So 3, 4, and 5 is 12, 4, 5, and 6 is 15. That's why I'd go with the numbering from the left rather than the right.
Is there like a reason for that, or is that just to simplify the naming?
It's to simplify the naming.
Okay.
It's so that, you know, we don't have two names for every single structure.
Right.
So that's why we number it from the left to the right, starting at 1 and going all the way through to 8. Does anybody have any questions about this so far?
The numbers that you're getting, the 3, 4, 5, that's what carbon it's on, correct?
That's correct. In that, yeah, in the chain, that's right.
Okay.
Well, those are the only carbons that have functional groups hanging off them. Let's put it that way. So the base chain is what I've circled originally. I changed the color, but I really can't be bothered. So I'm hoping I'm hoping you're okay. It's just going to be a little bit too much trouble for me to change the color on that one. But what's important here is I've circled the functional groups that are attached here. And now what I'm going to do is name those functional groups. This one here is ethyl. This one here is ethyl as well. And this one here is isopropyl. All right, let's go take a look at the functional groups. And those are here. Now remember, you don't get that third column. But you can see the ethyl would be 2 carbons, and there they are here, CH2CH3, CH2CH3. The isopropyl is this one here. It's got the CH with the 2 methyls on it, and there's your CH and your 2 methyls here, so that's isopropyl. But you will get this sheet here that does show the side chains. Does anybody have any questions? All right, so the next thing we do is we have to put all that together, and the side chain groups go in alphabetical order. But it ignores prefixes like di and tri, which would be there to have multiple groups of something like we have here. We've got 2 ethyls. That's going to be diethyl. But the di part isn't part of the alphabetization. So it's only the E and the I that we're interested in for the alphabetization. And things like N out the front, that doesn't affect the alphabetization either. So let's go back to the, actually I'll go back to here. So the ones that affect the alphabetization, let's see, we've got N-butyl. Now sec-butyl, no, it's not S, it's B. Isobutyl is actually I, because there's no dash in between iso and butyl. But anytime there's a dash, it's only the, you know, the sec doesn't matter, the tert doesn't matter here either. And the end and then doesn't matter for alphabetization. So when I come up with the name on this one, it would be 3,4-diethyl, and then 5-isopropyl octane. Now that's all one word at the end there. Sorry, I ran out of room. 3,4-diethyl, 5-isopropyl octane. You can see the name here. You'll notice there's no spaces or anything here, just dashes. So the way it's formatted is you have the numbers that indicate the locations of those 2 ethyl groups, 3 and 4, and those are separated by commas. And then there's a dash here, and then the group, and then a dash separating the numbers from the other groups. So that formatting is going to be important. All right, any questions? Now these cycles are a little bit more challenging, especially with the initial numbering. So we've got our name here. Oh, sorry, we've got our structure, which I'm going to draw as a line structure.
Professor,
Yeah.
on the exams, you will give us you give us the names, right? Like the CH3 and the CH.
Yeah.
Like you won't give us the line structure only, right?
Right.
Okay, so the names will come with the structure.
Yes, but not the
Okay.
not the base change. You can just know the base change, Nora.
Okay.
Anyway, you can look at an old test to determine exactly what you get and what it looks like. All right.
Yeah. Yeah. Okay. Thank you.
So what I have to do now is figure out how to number this so that I get the lowest possible numbering set. Now, going back to the previous one, I do actually have a little bit of a hack for that. So what you can do is you can look at the structure and just figure out which end everything seems closest to. I call it the busy end. And that's the place you usually number from. So you can see it's pretty clear you have to number from the left here to get the lowest numbering set. But for something like this, it becomes a little bit more difficult. So the numbering set, what I would do is I would base it on, well, where most of the stuff is in the structure. And that would be this side here. It'd be the right side where all the stuff's hanging off. So I know I'd start my numbering from there, and then I number through the busy area. So 1, 2, 3, 4. And if I do that, then that'll give me the lowest possible numbering set. So it'd be 1, 2, 3, 4, 5, 6. So as you can see, you can try other ways of numbering, but they're going to end up giving you larger numbers on the substituent groups. So of course, the substituent groups here are the ones I'm circling. And you see this would be 1, 2, and 4. You can't get any lower than that on the numbering. Anybody got any questions? Now, as far as the name goes, I'd have to write down each of those. We've got methyl, we've got ethyl, and then we'd have propyl or N-propyl. It doesn't matter which one you use there, but I'll go with propyl. So those are the three substituent groups. So we'd be using M, E, and P as the basis of our alphabetization. So it would be 2-ethyl, and then it would be 4-methyl, and 1-propyl. And it would be cyclo, it's all one part of the name. I didn't ran out of room here. Cyclopentane, hexane, sorry, hexane. So you go 2-ethyl, 4-methyl, 1 N-propyl or propyl, it doesn't matter. Cyclohexane. You'll notice I've got that for both of them here, propyl or N-propyl. That'd be fine.
Does it matter where you, like in the name, you put them? Like,
yes, they have to be alphabetical.
Oh, yes. Okay. I forgot. Thank you.
Yeah. Not by number. Okay, that's the mistake I see a lot of people make. Or they forget the alphabetization altogether. But it's important, things like sec-butyl, it's based on the B, not the S. Whereas isobutyl is based on the I. So it takes a lot of practice, you know. Let me show you the naming alkanes here. I have this fun quiz, and the idea is there are 10 questions on the regular quiz. There's 40 questions on the credit quiz. This is extra credit though. You know, you don't have to actually do this, but you know, it's good practice, I think. Now you've got to format the names properly, and they're all or nothing. For group prefixes, use T, not tert. Use an. Do not use an for propyl or butyl. Number all groups on cyclic compounds. If your answer has been marked incorrect, send me the attempt and I'll take a look at it. But make sure you follow these rules when you're doing the practice quiz here. I'll show you what it looks like. So there you go. Yeah. Now this top one up here, that's called a phenyl. That functional group's called phenyl. It's not actually on the list, and you won't be given that on any test, but I wanted to include it so that because I've got a lot of compounds that contain it. Oh, here we go. 3 double bonds in a ring is called a phenyl group. So that would be the phenyl group there. So you put the names in here, but they have to be exactly right. All right. Does anybody have any questions? That's good practice. All right. I'll show you what else is good practice as well. And this is in the blue book. And functional groups. Okay. So got that. I've already into that. Okay. So I've got some examples here. These are just hydrocarbons, and they have the structures with them as well. And then I've also got another worksheet here starting on page 28. That's good practice. It has the names and the structures here. Now on the test, you've got 2 questions. So these are the questions here. 8 is going from names, the names to the formulas, and the other one goes from the formulas to the names. So keep in mind these should be properly formatted. I fantasize about this. I do. I fantasize about putting wrongly formatted names here and then giving points for actually being able to determine the proper formatting for the name. I fantasize about it. I don't do it, but I fantasize about it.
So I have a quick question. Do we get partial points for these kinds of questions?
No. No, they're kind of all or nothing, Sarah. I mean, you know, you either draw it right or you draw it, or you have the right name or you don't.
Okay, thank you.
Yeah. But, you know, if let's say, all right, let's say you're looking at this. Let's say you completely forget about formatting. You have no clue how to format names, or you completely had a blank, right? Is there anything you might be able to get a clue from that might give you an idea about formatting for these names? Any ideas? Any thoughts?
Going back the other question.
Yeah, go back to the other question. If your name's not formatted like those, I think you probably got it wrong. So, I don't know. You have to be careful. I'm not going to say it doesn't take care. It does take care. It does. Yeah. All right. Does anybody have any questions? Any questions at all about the naming here for now? All right. Well, you got a lot to practice. You know, you got those fun quizzes to do. I'll get a start here on the. Whoops. I'm in the wrong place here. I'm sorry about that. We'll continue on with this next part here is the alkane reactions. And we'll just get a start on it today, and I'll finish it up on Wednesday, and then we'll be spending the rest of the time hopefully on review. So radical reactions of alkanes. I don't really want to go into the chemistry of it too much, but what happens is that the same thing happens in the atmosphere with the destruction of the ozone layer. You've heard of chlorofluorocarbons, I'm sure, destroying ozone. Well, what they do is they break apart due to cosmic rays, and they form these things called radicals, which are single electron species. So if you've got something like chlorine in the atmosphere, what would happen is light would hit it, and it would split into these two radicals here, which are uncharged particles, but they have single electrons, and they are very, very reactive. So for something like this, the Cl2 would split into two things. We call that initiation. And then we've got propagation, which is kind of like a chain reaction, where you've got a radical reacting with something that is not a radical, and that produces another radical. So that's how one chlorofluorocarbon molecule can destroy 100,000 ozone molecules before it gets destroyed. And the way it gets destroyed is by reacting with another radical. So that's called termination. That's when two radicals come back together. But I want you to focus on what happens when we're dealing with chlorine and where it can go on the molecule here. So the idea is, and this is the pattern, and I'll show you this over here. So I'll do this top one here, just to give you an idea of the pattern. So we've got CH3 on one end here. And then we've got the Cl2. And you might see light, or you might see this H nu, which is energy from light. So you'd have to think back to General Chemistry 1 to remember something like that. And the product here is only one. Would have the Cl replacing one of these hydrogens. And the hydrogen that was on this carbon atom here joins with the other chlorine. So that's the pattern I want you to notice that we're showing here. You'll also notice that I could have replaced any of these hydrogens, but in doing so, I would have ended up with the same structure. So we're kind of doing something a little bit like what we're doing with the isomers here. So you'll notice that for something like this, there is only one product with the ethane. With the propane here, the 3-carbon, the chlorine could go in the middle or it could go on the end, and your HCl is also. You'll notice this isn't balanced, but I don't care if it's balanced or not. I just want the products. And if it's a hexagon, they're all the same, so the chlorine can go on any one of these. It'd be the same thing. Does anybody have any questions so far? The other reaction we look at is this one, and that's combustion of alkanes. And the only products we get are CO2 and water, and that's all you have to worry about. We don't even have to worry about balancing those. But I'm going to show you what the test question looks like. Well, that's probably not a good example. Let me go back to the original. I'll pull up an old test question here. I think I just did that again, didn't I? Damn it. No. All right. So the last question here. There you go. So for the first one, that's just going to be CO2 and H2O as the answer. And I don't need that to be balanced. If you want to balance it, have at it. Now for the other one, I've told you that the Cl is going to go on each different carbon atom. Now to do that, what you might want to do is label it. And if you want to, I could label each different one. That'd be A, B, C. This will be A. This will be C. This will be B. That's A, B, and C. Oh, that's a bit of a challenge, isn't it? What concept am I employing there in order to have the same letters on different carbons? Can anybody come up with the word I'm looking for here?
Isomers?
A symmetry. No, symmetry. So there's a lot of symmetry going on here. So each of those A, B, and C can have a different chlorine on it. So one of these would be that. And we could have a chlorine here. Whoops. And we could have a chlorine here. So all of those would be the three structures, and then you'd have plus HCl as well as a product. And that would be the answer to this one here. Now I do have in the blue book, and I'll just show you this quickly before we head out here. I have a worksheet for this. Or where's the worksheet? No, the worksheet, actually I think, no, the worksheet is in the, I think it is in the blue book, but I think it's also in this folder down here, Alkane Reactions. Yeah, I think that's got the worksheet on it. Here we go. I think there's a worksheet in both places actually. I don't think this is in the blue book. So this has the questions and the answers on it. So that's the H nu I was talking about. That just means light. So I think if you can understand those, you should be good. So that's something for you to look at as well. Again, we'll talk about this more on Wednesday. This won't be the last we'll talk about this. We'll talk about this maybe in the first 15 minutes, and the rest of the time we'll be able to do review. Then we'll have the test will be the Wednesday after Labor Day. All right, so we'll leave it there for today, and I will talk to you all on Wednesday. If anybody wants to hang around, ask me questions, they may. The rest of you, bye.
Thank you.
Bye,
You're
thank you.
welcome.
Thank you.
Thank you.
Have a good day.
You too. All right. So it's Francisco, Nora, and Ryan. Nora, did you have a question?
Yeah, so I know the test is coming up and we need a printer and all. So
you don't
I
have.
tried.
Well, Nora, as I said, just let me know you don't have a printer, and you can read it off the screen. Okay.
Okay. All right.
And put it on a separate sheet of paper. You don't have to write the questions down, but you do have to do them in the same order as they appear.
Okay, but what if I can go like somewhere, but they have a desktop, like not a movable laptop. I can show you a 360 of the room, so the mirror comes into place, right?
Yeah, that's right. You need a mirror there. Yeah.
So if I go somewhere with like a desktop, like I can't move it, but there's a printer.
Yeah, you can do that.
So I could just use the mirror to show you the
Sure.
desk and then just do my work there.
That's right.
Okay, thank you.
All right.
All right.
See you,
Have a
Nora.
good day.
Bye. Francisco, do you have something?
Yeah, my printer's in the other room. I can just print and come back to
Yes,
my desk
absolutely. Yeah, that's fine.
and then use the mirror, which is coming today.
Yep. Okay, cool. You don't have a mirror?
I ordered it on Amazon yesterday. Yeah. So.
Oh gosh, I thought everybody'd have a mirror. Oh gosh.
That's like $5.
Oh golly. All right, all right.
Hey, whatever Dr. Musgrave needs, so I can.
I'm sure you could have found something at a dollar store if you went. You know.
Yeah, but yeah.
You couldn't be bothered. Fair enough.
Yeah, lazy. And another thing, I have a question about tomorrow's lab. I've turned in my the pre-lab.
Yeah.
What else do I need for tomorrow? Just do I have
That's
to finish
it. No, you're good. You're good to go. So if you don't even have to, if you don't want to, you don't even have to turn up tomorrow. But because you've already done the thing, and the thing's not due until the report itself isn't due for another week. But I'll be there to go through things and help you with stuff.
Okay. Yeah. All right. So I have everything finished because I thought it was due tomorrow. So what I'll do is I'll probably show up tomorrow and just pick your brain and make sure that I can get the maximum points available.
All right. Sounds good.
Excellent.
You.
Thank you so much.
No worries, Francisco. Talk to you later.
Bye.
Ryan, you there, buddy? All right. All right. See you later.